Very good morning, students. Today we are going to discuss the unit 4 partial derivative and the topic is total derivative. So start the total derivative. Right? In this, first I am going to tell you the chain rule. Chain rule. That is, if z is a function of u, where u is again a function of two variables x and y. Example, suppose u is a function of phi, x and y. Okay, then the chain rule. Students, here our given function, main function is z, right? And it is, z is depends on what? It is depends on u, and u is depends on x and y. Okay, so if I want to the derivative of z with respect to x, that is del z by del x. Okay, because at the end of there are two variables. So I'm writing that is dz by du. dz by du. Listen carefully. I am applying here d, ordinary derivative, because z is depends on one variable only. So I am writing here dz by du, and u is depends on two variable, and I want with respect to x. So that is del u by del x. Okay. Or I also write as df by du, because z is again a function of, this is f of u, right? So I am also write as df by du into del u by del x, or the other notation del f by del u, that is f dash u into del u by del x. So we represent our del z by del x with this way or this way also. Yes, Abhay, ask your question in chat box. What happened? Similarly, if I am going del z by del y, that is, okay, by mistake, it's okay. Yes, Yogesh, we can write same way for y, that is dz by du, see this is d, not del, dz by du into del u by del y, or we can say del f by df by du into del u by del y, or f dash u into del u by del y. Students, this rule is known as chain rule. Okay, now we'll move for composite function of one variable. Composite function. Abhay, please, your hand is still raised. Any doubt? Okay. Okay. Uh, Two Abhays are there. Please, There are two above. Please leave the meeting, the other one who are not in the student of this class. Now, composite function of one variable. Okay. So, in this topic, if u is equal to f of xy, where x is equal to phi of t and y is psi of t, then u is a function of t is called composite function of one variable t. See, in this case, our given function u is depends on two variables, right? X and y. And x and y both depends on one variable, that is t. Look at the difference between the composite function of one variable and chain rule. In chain rule, one function is depends on the other one, and that other one is depends on two. But for the composite function of one variable, one function is depends on two variable, and that two is depends on the same variable t, right? At that time, if we want to find the derivative of u with respect to t, that is du by dt. Okay, here one variable at last depends on one variable. So I am applying here du by dt. That is, here u is depends on two variables. So I am applying here partial derivative. Del u by del x, and x is depends on one variable, that is dx by dt, plus del u by del y into y is again depends on one variable, so I am applying ordinary derivative. Students, this point is very important. Please listen carefully. Here I want the derivative of u with respect to t. So there is one variable, so I am applying the ordinary derivative, that is du by dt, right? But for that, u is depends on two variables. So del u by del x into dx by dt. Similarly, del u by del y, because u is depends on two variables, so I am applying first partial derivative, and that two variable depends on one variable, so then after I am applying the ordinary derivative. Okay, and this is called, it is called total derivative of u. Total derivative of u. No, both are different. Del and d both are different. D notation is used for the ordinary and del notation is used for the partial derivative, right? So you have to apply d and del, whichever is applicable. Got it, Yogesh? Okay. Now, suppose if I have given u equal to f of x, y, z, right? And your x is phi t, y is psi t, and z is xi t. Okay. And in this case, if I want the total derivative, then what is your total derivative? That is du by dt del u by del x into dx by dt, right? Because at that time your u is depends on three variables, x, y, and z, and all that three variable depends on t. So here del u by u depends on three variables, so I am applying partial derivative. That is del u by del x, but x is depends on one variable, that is ordinary derivative dx by dt. Similarly, for y, del u by del y into dy by dt plus del u by del z into dz by dt. Kalp, what is your doubt? This is xi. Z is equal to xi is uh, this one is phi, this one is psi, and z is xi. Xi is a function. It is a function name. Okay, this is the function name. Now got it? This is the function. See, x is phi. See, I am applying his phi. This is psi, and this is xi. This symbol is known as xi. Okay. So, students, have you any doubt in this topic? If understood, when the function is applied on more than one variable, then we are applying or the partial derivative, and then we apply the total derivative. Okay, so let's start the example for the better understanding. That if u equal to y square minus 4ax and x is equal to 80 square, y is equal to 280, then find du by dt, right? See, it means in this case, your given function u is y square minus 4ax. X is 80 square and y is 280, right? So u depends on two variable, x and y, and x and y both depends on one variable, that is t, because here a is constant. So I am applying the total derivative rule, du by dt, that is del u by del x into dx by dt plus del u by del y into dy by dt. So the partial derivative of u with respect to x, we are applying partial derivative. So here y is constant. So our answer is here minus 4a, right? Dx by dt, the derivative of x with respect to t, that is 2at plus del u by del y 2a, and dy by dt, the derivative of y with respect to t. So here uh, this is del u by del y, so 2y, right? And here 2a, this one is y. So minus 8at plus 2, the value of y is what? Value of y is 280. This is 280 into 2a. Substitute value of y. So here 8a square t, right? So minus 8a square t. This one is plus 8a square t. So minus plus 0. Any doubt? Any doubt? Okay. So let's take one more example. If u equal to x square plus y square plus z square, where x is e raised to t, y is e raised to t sin t, and z is e raised to t cos t. Find du by dt. So in this case, u is x square plus y square plus z square, right? X is e raised to t, y is e raised to t sin t, and z is e raised to t cos t. It means your u is depends on xyz. Here u is depends on xyz, and this xyz is depends on t. So for the formula of the total derivative du by dt, that is del u by del x into dx by dt plus del u by del y into dy by dt plus del u by del z into dz by dt. So E is equal to, here del u by del x, the derivative of u with respect to x, what is that? That here we are applying partial derivative, so 2x, right? And dx by dt, so the derivative of x with respect to t is e raised to t plus derivative of u with respect to y, 2y, and the derivative of y with respect to t. There are 2 times t, so we are applying the multiplication rule. Here the derivative of e raised to t is e raised to t, sin t keep it same, and e raised to t remains same, and the derivative of sin t is cos t. Now for the del u by del z, we have 2z and del z by del t, that is again for the multiplication rule, the derivative of e raised to t is e raised to t, cos t keep it same, and e raised to t keep it same, and the derivative of cos t is minus sin t. So now I am putting the value of x, y and z here. So x is what? E raised to t. So 2 e raised to t into e raised to t plus 2. In the place of y, I am putting here e raised to t sin t. And this is e raised to t sin t plus e raised to t cos t. And in the place of z, 2 e raised to t cos t, here e raised to t cos t minus e raised to t sin t. So this is 2 times e raised to 2t plus 2 times e raised to 2t sin square t plus 2 times e raised to 2t. This sin t into cos t, that is sin t cos t plus 2 times e raised to 2t cos square t minus 2 times e raised to 2t cos t sin t, right? So here this term and this term will be cancelled out, both are same, one is plus, one is minus. So 2 e raised to t is common from the other term, so here 1 plus sin square t plus this, the remaining term is cos square t, right? So this sin square t plus cos square t is 1, and 1 is 2. So 2 e raised to 2t, 1 plus 1. So final answer is 4 e raised to 2t. Any doubt? Any doubt, students? If you have any doubt, please ask in the chat box. If no doubt, then we'll move for the other example. I expect the answer from all of you. You have to just write down your doubt, and if you have no doubt, then please write down that no doubt, or at least no. Okay. So we'll move for the another example, that is if z is equal to e raised to xy, where x is equal to t cos t, y is equal to t sin t, find dz by dt at t equal to pi by 2. Find dz by dt at t equal to pi by 2. So let's start the solution. Here z is e raised to xy, where x is t cos t and y is t sin t. It means your function z is depends on x and y, and x and y both depends on one variable, that is t. Okay, so the total derivative formula dz by dt, that is del z by del x into dx by dt plus del z by del y into dy by dt. Now, the derivative of z with respect to x. Okay. Now, I am going to unmute all of you. I, I, I expect the answer from your side for that. Okay. Okay. Now, tell me the derivative of z with respect to x. Partial derivative of z with respect to x.
E raised to xy into y.
Very good. E raised to xy into y. And the derivative of x with respect to t. Fast.
T into minus sin t plus cos t.
T into minus sin t plus cos t. Okay.
Cos.
Then the derivative of z with respect to y is
e raised to xy into x.
yes. And the dy by dt is
T cos t plus
T
sin t.
cos t plus sin t.
very
T
good.
cos t plus sin t.
Okay, good. Right? Okay. Now, see, I want the total derivative at the point pi by 2. So, if t is pi by 2, okay, if I am taking t equal, because I want the value at pi by 2. So, what is the value of x? If I put t equal to pi by 2, then what is the value of x? That is pi by 2. Yes, that is pi by 2.
0.
Yes, very
0.
good. Yes, good, good. Cos
X equal to 0.
x equal to 0, because cos pi by 2 is 0, and 0 into pi by 2 is 0. And similarly for y,
Y is equal
1.
to pi by
Pi
2.
by 2.
Pi
very
by
good,
2.
perfect. Okay, so now dz by dt at the point t equal to pi by 2, that is, see, now I am substituting the value of x and y here, right? So e raised to 0 into pi by 2, that is e raised to 0. And you all know e raised to 0 is 1. So no need to write here 1. And the value of y is pi by 2, right? At the place of t, I am putting here pi by 2. But sine pi by 2, this is minus sine t. And sine pi by 2 is 1. So minus 1. Cos pi by 2 is 0. Okay.
0.
Okay. And in the last term, in this term, if I put 0 in the place of this x, then 0 into anything is 0. So my last term will be 0. And after simplification, my final answer is minus pi.
Minus pi square by 4.
Perfect. Good. Okay. So I think no doubt. If anyone have any doubt, then you can ask. Otherwise, we'll move for the other example. Okay. Have you any doubts, students?
No doubt.
Okay.
No doubt.
Okay. So we'll move for the other one, that is the composite function of two variables. Composite function of two variables. We have done the example for the composite function of one variable. Okay, now we'll move for two variable. That is, if z is equal to f of xy, where x is equal to phi of uv and y is equal to psi of uv. Okay, then z is a function of two variable x and y. Z is a function of two. So z is a function of finally two variable u and v is called is called total is called the composite function is called the composite function of two variables u and v. See, I am drawing a tree here. Here z. Z is a function of two variables x and y, right? And this x and y is again depends on two variables u and v. This is also depends on u and v. This both u are same and this v are also same. Okay. So if now if I am going to the derivative of z with respect to u, then I have two ways. The derivative of z with respect to x, then with respect to u. Similarly, the derivative of z with respect to y, then with respect to u. So here I have to write down the del z by del u. Okay, because there is at the end there are two variables. There is no one variable. So I am applying here partial derivative. Derivative of z with respect to u. For that, I am my first path, that is del z. See, there are two variables. Okay, so del z by del x into del x by del u plus del z by del y into del y by del u. Similarly, for v, if I want the derivative of z for v, that is del z by del v, then del z by del x into del x by del v plus del z by del y into del y by del v. Okay, so let's take example for this for the better understanding. Suppose my question is, if if z is equal to f of xy and x is equal to e raised to u plus e raised to minus v and y is e raised to minus u minus e raised to v, show that del z by del x minus del z by del v is equal to x del z by del x minus y del z by del y. Okay, this is my question. So let's start the solution. See, here my function z is depends on two variable x and y, right? And this x is depends on uv, y is also depends on uv. Okay, so let's start. Here z is f of xy, x is e raised to u plus e raised to minus v, and y is e raised to minus u minus e raised to v. So the first derivative of z with respect to x. Okay, the derivative z with respect to u. So for that, you know the path del z by del x into del x by del u plus del z by del y into del y by del u, right? Any doubts, students? Students, have you any doubt?
No, ma'am.
Okay,
No, ma'am.
okay, good, good. So, yes, okay, okay, good. So the derivative of z with respect to x, right? So here I have the in general function, so I am putting del z by del x, same. But for the del x by del u, the derivative of x with respect to u, that is e raised to u. Similarly, for del z by del y, I am putting the same term, del z by del y. But for the del y by del u, that is minus e raised to minus u. Okay, this is my equation 1. Now, for equation 2, that is del z by del v. Okay, del z by del v is del z by del x into del x by del v plus del z by del y into del y by del v. So similarly, I am putting del z by del x, keep it same, and for del del x by del v, that is minus e raised to minus v, right? So here minus e raised to minus v. Then del z by del y, keep it same, and the derivative of y, uh, that is
Minus e raised to v.
perfect, minus e raised to v, minus e raised to v. This is my equation 2, right? This is del z by del v. And else, see, we want the del z. See, what is our left hand side? Del z by del x minus del z by mistake I write here x, this is u, right? Del z by del u minus del z by del v. So we are taking the subtraction of 1 and 2. Okay, so I'm going to subtract equation 2 from 1. Subtract from 1, that give you the answer del z by del u minus del z by del v. Okay, so what is my equation 1 here? Del z by del x into e raised to u, del z by del x into e raised to u minus del z by del y into e raised to minus u, right? Del z by del y into e raised to minus u. Now minus, okay, I'm going to subtract. So this minus minus both will be plus. So here del z by del x e raised to minus b plus del z by del v del y into e raised to. Students, any doubt? Any doubt?
No, ma'am.
No, ma'am.
Okay, so now I am taking the common del z by del x from term 1 and 3. Okay, so if I am taking common del z by del x, the remaining term is e raised to u plus e raised to minus v. Okay, and if I am taking minus del z by del y common, then the remaining term is e raised to minus u. I am taking minus common, so this plus will be converted into the minus, that is e raised to v. Okay, so see, let's check. This x is e raised to u plus e raised to minus v. So e raised to u plus e raised to minus v. So this is x. Okay, minus del z by del y, and this is e raised to minus u. Okay, this is e raised to minus u minus e raised to v. This is our y. So this is our proof what we want to prove. Okay, see your question. See, del z by del u minus del z by del v equal to this x into del z by del x minus y into del z by del y. Okay, so got it? Okay, got it, students?
Yes, ma'am.
Okay, so let's take one more example. That is, if u equal to f of x minus y minus z, z minus x, then then show that del u by del x plus del u by del y plus del u by del z is equal to 0. Okay, so let's start the solution here. Suppose I take, students listen carefully this example. Suppose I take L is equal to x minus y, M is equal to y minus z, and N equal to z minus x. See, I am taking this first x minus y as L, this one as M, and the last z minus x as N, because it means my u is depends on, if I am assuming here L, M and N, it means my u depends on L, M and N. Okay. And these three L, M and N variable, it's again depends on three variable X, Y, Z. So Here, this L, we want the partial derivative of del L by del X, that is 1. Del L by del Y, that is minus 1. And del L by del Z, but there is no Z, so it is 0. Similarly for M, del M by del X, that is 0. Del M by del Y, that is 1. And del M by del Z, that is minus 1. Del N by del X, minus 1. Del N by del Y, 0. And del N by del Z, that is 1. Okay. Now, the derivative of u with respect to x, I am finding the derivative del u by del x. Okay. Then I have to move with 3 rules. The u with respect to L, this u with respect to L, then x. U with respect to M, then x. U with respect to N, then x. Okay. So I am writing the formula here, that is del u by del L into del L by del x. Del u by del M into del M by del x. And the third one is del u by del N into del N by del x. Okay. Now I am putting the del u by del L, keep it same, and the derivative of del L by del x. Okay. See this one, del L by del x. The first is 1, del M by del x is 0 and minus 1. Okay. Keep remembering 1, 0 and minus 1. So I am putting the del L by del x is 1. Del u by del M, keep it same. This is 0. Del u by del N, this is minus 1. Okay. So this is del u by del L minus del u by del N. This is my equation 1. This is for del u by del x. Similarly for del u by del y, that is del u by del L by del y, del u by del M by del y, and the last one del u by del N into del N by del y. Okay. Now see value with respect to y. L, this one is the derivative of L with respect to y is minus 1. M with respect to y is 1 and N with respect to y is 0. Okay, so minus 1, 1 and 0. Now I am putting the value of del u by del L, keep it same. And as you know, the value of del L by del y is minus 1, 1 and 0. That is here minus 1, del u by del M, 1 and del u by del N, and that is del N by del y is 0, right? So the final answer is, this is minus del u by del M plus del u by del M. Minus del u by del M plus del u by del M. This is my second equation. And the third, if I go for the del u by del Z, then del u by del N into del L by del Z plus del u by del M into del M by del Z, same del u by del N into del N by del Z. Okay, now the value of partial derivative of L, M, N with respect to Z, L, M and N with respect to Z is 0, minus 1 and 1. So this is 0, this one is minus 1 and this one is 1, right? So minus del u by del M plus del u by del N. This is my equation 3. As we want the summation of these three, del u by del x, del u by del y and del u by del z, right? We want the summation of these. For that, add equation 1, 2 and 3 By adding equation 1, 2 and 3, we have del u by del x plus del u by del y plus del u by del z is equal to, so what is my right hand side of the equation 1? That is del u by del l minus del u by del n. Del u by del l minus del u by del n. For equation 2, minus del u by del l plus del u by del m minus del u by del l plus del u by del m. And the third one is minus del u by del m plus del u by del n minus del u by del m plus del u by del n. Okay, so this one is plus, this one is minus, negative, positive, and this both will be also cancel out. So final answer is 0, which we want to prove. Okay, so this is the proof of the given example. In this case, our u is depends on lmn, and this lmn is depends on the other three variables. So we are applying the composite rule for two or more than two variables. So any doubts, students? Students, have you any doubt?
No, ma'am.
Okay, so in our yesterday's lecture, we have did 3 example. Okay, that are the importance example, and in today's lecture, we do the total derivative, and for the total derivative, at least one example, one or two example every year asked from this topic. Okay, so if you have any doubt regarding today's lecture, then you can ask in the chat box. Otherwise, you may leave. Thank you.